Happy Easter, Form 5 boys and girls. Today I would like to give you the new topic of Chapter 9, which is called the Cosine Formula. But before I go to the new session today, so what I want to do is that I would like to give you the recall of what you've learned in the last session. So if you still remember, last session we start talking about solving triangles. That means that we deal with any type of triangles, not only right angle triangle you learn in Form 2 and 3, but also now we have to learn all types of triangles. That means no matter acute angle triangle or obtuse angle triangle. So if you still remember, last time we first learned sine formula. So if you still remember, sine formula is talking about what? So actually sine formula is talking about the relation between the length. For example, when we say A, M is corresponding angle, which is the angle opposite to the side. For example, when we say the angle A, okay, should have the same proportion among every pairs of angles in side. So we can just say A over side A equals to B over side B. And also, if you still remember, we will say that A over side A and B over side B, actually we have the relation of this one, because this one can also represent by 2r. So you should still remember is that this r is what? Is the radius of the circumcircle. Okay, of the circumcircle of the triangle. Okay, so what does it mean? So if you still remember, we will say that, okay, the sine formula actually is talking about the geometry about the circle, and within this circle, okay, there would be a triangle inscribed. So actually this circle should be called the circumcircle of this triangle. And also we will say that the center, okay, the center of the circle should be the circumcenter of the triangle. So if you also still remember is that, if you still remember for the sine formula, so what we need to say is that we prove by drawing a diameter pass through the circumcenter and pass through a point here to get the relation that we want to know. For example, if I say this one, okay, for example, if I say this one and these two angles by the same segment, and also if I say this one is A and A here, so actually the relation comes from this. Why you have such a 2r is because of this. And also we will say this one is actually 2r because this is the diameter of the circle. So actually this one is a sine formula. And also, if you still remember, is that when we talk about the sine formula, what you need to do is just you have to understand when we can use a sine formula is that we have a pair of sine and angle, and also another pair of sine and angle. That means that the sine and angle should always opposite to each other. That means that we can only focus on two types of triangle. We say the three types of triangle. The first one is the triangle with two angles, because once you have any two angles, by angle side triangle you can get the third angle. So two angles with a side, including ASA or AAS, can be applied using the sine formula to solve the triangle. Besides of this, you should also remember is that the triangle with SSA, okay, can be also used for sine formula, because you have two sides and one angle opposite to one of the sides, so you can find another angle opposite to the other side, so you can find all the angles as well as all the sides. But do remember is that because this one is not congruent triangle. So if you still remember what I said in the last clip, okay, so we will say that, okay, for SSA triangle, the answer may not be unique. That means that may not be only one. Why? Because we will say that for this situation, the angle can be acute or obtuse. But it just depends on what is the figure. Because if you have found such a result, for example, when we say sine theta equals the value, then you can recall is acute angle or obtuse angle. But when we can only have one answer, is that we have to see the length of the side, because we should always obey the law of greatest angle, longer side. So I would like to recall once again here is that you should remember the rule is the greater angle, okay, and then you have the longer side. So you should always keep in mind this idea to see whether the answer that you find from sine formula is suitable for your situation. So always remember using this rule to distinguish whether you have to keep all the answers or you have to keep both answers. because when we talk about, okay, when we always say that, for example, if I say sine theta, for example, I say sine theta equals to something, so that thing should be positive number because you are comparing the sizes of the triangle. So you will always say that the angle you find, for example, we say alpha, you should have another one. But do remember to see whether these two angles is suitable for this whole situation, because if the angle you find facing to the shorter side, so you should not have the very great angle here. So you have to keep in mind to see whether the answer is valid or not. So this is the sine formula. But do remember is that you can see that when we talk about the sine formula, actually you can only do with these three types of triangle, which is ASA, AAS, and SSA. So there will be also three types of triangle that we cannot consider. So you have to use another formula to solve those problems. So why do we have to introduce another formula, which is called cosine formula? And do remember is that the cosine formula is used for solving another kinds of conjugate triangle. So you should know another kind of triangle will be these two. First of all, the SSS and also the SAS. But because of the order, I should write the SAS first, okay? Because the long history, when we talk about the Euclid, a very ancient times mathematician who developed geometry, he find the SAS triangle first. We also say the SAS first and then the SSS. So you may also wonder whether RHS, okay, can be found. But actually RHS you don't need to use the cosine formula and sine formula, because actually you should know that this one you can simply use only sine, cosine, tangent for RHS, because once you have the right angle triangle, you can use sine, cosine, tangent to solve the problem. So this one just ignore it. But anyway, we will say that for cosine formula, this one we are dealing with SAS and SSS triangle. Okay, so this is what I would like to tell you first, okay, about the cosine formula. And also I would like to say that the cosine formula is a little bit long comparing with sine formula, and you will also see that the formula actually may be a little bit complicated, okay, when we compare the form of the sine formula. But I would like to say is that cosine formula actually is easier to use, because what you need to do is just you apply the cosine formula always, and you don't need to consider whether you have cases just like using the sine formula you may have two solutions. But for cosine formula you can never get two solutions unless you are doing wrong, okay? Why? So we will investigate now. But just remember is that the formula would be a little bit special, because you can see the formula, okay, as you can see the book would be something like this, which we say a squared equals to b squared plus c squared minus 2bc cosine a, and also their symmetrical form, for example b and c as subject like this. But you can see actually this formula is a little bit familiar to you. Why? Because if you just cover the last part, just see the a squared b squared plus c squared, so this one is very similar to Pythagoras theorem, very similar to Pythagoras theorem. But actually this is not Pythagoras theorem, because you are not doing with right angle triangle. So this one I will just say similar to Pythagoras theorem, but not actually Pythagoras theorem. And actually, if you want to memorize this formula well, okay, I strongly suggest you reading the proof that you can see in the book. So I can't remember it's which page, but so you can just turn over the book to about the chapter 9.2, then you can see that the detailed proof is shown, and it is also correct, okay, in the book, to show how can you show the cosine formula works for triangle. Actually, it divides into two cases: acute angle triangle and obtuse angle triangle. For right angle triangle, you don't need to do so, because actually the first part is the Pythagoras theorem, so it's satisfied, and the last part, because the angle considering is 90 degrees, so you will have this part 0. That means that you just cover the last part, it is Pythagoras theorem, and also it is applicable to right angle triangle. Very easy. By the way, so you can easily see that, okay, the proof is something like this. Just use Pythagoras theorem twice to get such an answer. So this one I just leave it for you to read by yourself. But actually the cosine formula is a very important formula, because actually once you have put all the things here, you don't need to consider, okay, what you have, just read the answer directly. And do remember is that for using the cosine formula we have two forms. The first form is this way, and the second form is rearranging the cosine angle as a subject, and then you put all the sizes on the right hand side in terms of square, and also 2ab or 2bc, something like this. Then it is another form. Actually, these two forms are solving, okay, the SAS and SS triangle respectively. For the first one, because you have to find the last length, that means that you should have given two sizes and angle. So this one is used for SAS situation. That means that when we have the size, angle side, then you can find the first size using the subject is the first side in this way. And then you can easily see that the second form, if I write angle as a subject, that means that you should have given all the sizes, because you can see on the right side of your expression, all the things are in terms of the lengths. That means that you are doing with SS triangle, then you find either one of the angles among the triangle, then you can use this formula. Actually, this formula is also very important for you to know what? To know the angle size. Because for the properties of cosine function, you should understand that for cosine, okay, for cosine angle, when you have the positive, so you should know that when, okay, so it should not be when, it should be when you know that the angle is in your first quadrant for the triangle. That means that when we say cosine theta is greater than 0, so you have first quadrant. But when you may have this negative size, because you can see on the right side there should be a minus sign here, so that means that the right side expression may be negative. But you understand that if cosine is negative, it means what? It means a very important thing, that the angle you are considering should be in the second quadrant, or simply obtuse angle. So it's not surprising, because in the right is a triangle, you may have obtuse angle inside. That means that this is a very good distinguishment to let you know that what is the angle size, acute or obtuse angle, using the cosine formula. And also you can see that because cosine is positive only in quadrant 1 and quadrant 4, but you will not see any quadrant 4 angle in right angle triangle. So it is very easy to distinguish, and you will also see that because cosine is only positive in quadrant 1, only negative in quadrant 2, that means that you can never get the second solution, because unlike sine, because for sine, even in quadrant 1 and quadrant 2 both positive, but for cosine, one is positive, one is negative, so you can just only get one answer. So you don't need to think about whether the triangle is valid or whether there are more than one answer. So this is a very good formula. And practical, how should you use? So I think that you can just read the example by yourself. For example, now you can see in this triangle you are given these three things. So you can see the length here, and this one. So you can easily see that this one satisfies SAS because you have two sides. And do remember is that SAS, the A is between the two sizes. It means that this angle should be included angle. Okay, not the angle facing to either one of the sizes, but the two sizes should, okay, cover the angle, or the sizes actually generate the angle. So we call it the SAS. So once you can have SAS, then you have to first of all to use cosine formula to find the first side first, because cosine formula always you have three sizes and one angle in the formula. So once you have SAS, you should first of all find the first side. For example, you can see that it is our first target is that you find the first side. For example, you can see the small a here. So after you have got the three sizes, then you can actually apply the cosine formula once again by using this form, because once you have three sizes known, then you can find each of the angle by using this form. So you can also see that after you got the size here, so how can you find the angle? So you can just use the cosine formula once again. Okay, so it's not very difficult here. So once again, that you can also see the book will give you SSS here. So for the SSS here, actually this one is SAS. Okay, so you can just read by yourself. But anyway, I just want to say is that in order to solve the triangle, once you have got this one, so you can use cosine formula to do again. But just you can see it now after you have found the C here, so you can see you found the A by using the cosine formula, or also use sine formula. Why? Because once you have three sizes, so you should can find one angle pairing to which side, so you can also use sine formula to get it. But I don't suggest you using sine formula, because as we mentioned, okay, this one may have a problem is that, okay, so you have to distinguish, okay, you have to distinguish whether you have to take the smaller angle or larger angle. That means that you have to know that whether you have to find acute and obtuse. And actually, if you use the sine formula, you cannot see whether this angle should be acute and obtuse unless you are seeing the length of the sides. For example, if I say A, this angle here is corresponding to 14 cm. So when you take C to compare, you should really understand that the angle, this one for example A, or we just say the angle BAC is less than what? Sorry, I should not write here, so I simply to write here less than, okay, the angle ACB. Why? Because you have the length, for example here, the A is less than C. So you have this situation, then you can distinguish this. But just if you just see the sine formula itself, you cannot distinguish this. So actually it may be a problem to you. But remember is that by using cosine formula, you don't need to think such a thing, because actually this one, either it is positive or negative, depends on how large is the angle. If it's positive, you should get the angle smaller, because it should be acute angle, comparing with the angle C, which is obtuse angle. That means that always, okay, we are suggested to use cosine formula, because you don't need to think whether you have two solutions or one solution. But the disadvantage of using cosine formula is that you have to remember the formula very, very correctly, because in the formula of the cosine formula, you can see they are squared, and also there should be a minus sign, and also the multiple terms, for example 2 times b times c, the cross term, with cosine angle. So the formula itself may be longer, okay, comparing the sine formula. But when you use it, you see that cosine formula is an actually very convenient formula comparing with the sine formula. So do remember is that actually I'm strongly suggest you, as reminded in the book, using method 1, using cosine formula to solve all the things. Even you can use sine formula, and sometimes it may be faster. Okay, so this is the way to use the cosine formula. So actually you can see all the problems here, it's just like this. And do remember is that practically, okay, when you do your homework or your task and your test exam, you actually don't need to write by the cosine formula. That means that you can just simply highlight the triangle and start directly your formula using cosine formula with square root to get the length directly. That means that you can just simply to write a squared plus b squared minus 2ab cosine c with square root to find c directly. And actually this one you can skip. Just like here, I've already marked here, so you can skip this one. Okay, you can skip it and then to write directly that this one. Okay, so actually you can just see that when you take a look on the notes on the cosine formula, actually just use this way. Either use the SAS form or the SS form, the side as subject or angle as subject to find. And also do remember is that if you use angle subject form here, so do remember is that this one is starting from cosine. So always remember is that after you have got cosine theta equals something, don't forget to press this one by using shift cosine, okay, to find the angle. This is also a common mistake that many students make before. They forgot your subject, okay, of the cosine formula is cosine theta instead of theta. So some of them sometimes forgot to press shift cosine to find the angle actually. Okay, so don't forget to this. Okay, so this is actually not a big problem, but do remember to consider. Okay, so actually you can see it's very, very easy. Even you can see many example 11s here. And do remember is that sometimes you have to combine with two formulas to use in the whole problem. For example, you can see example 11 here, you have two triangles. Before you work on the triangle BDC, you may need to get the information from the triangle A dot, this one. But do remember is that this triangle is the triangle with AS, because you have AS here. That means that you should start from sine formula. Instead, you cannot use cosine formula, but cosine formula should be 2 sizes and include the angle of 3 sizes. That means that this one, okay, don't think that you can always use cosine formula to solve. Sometimes if you have a fixed congruent triangle, for example AS, then you use the sine formula first. And this one, you don't need to consider you have more than one answer, because this was AS is a congruent triangle. That means that all the things are fixed. So you should have only one solution. Just like what you start from the sine formula in this example, you can see that you find the length. So the length should be fixed, because you don't need to shift side to find the angle. So don't worry. So after you have got the sine, for example B dot here, so you can see in the second triangle BCD here, you have all 3 sides known. So this one is the SSS triangle. That means that now after you understood that this one is isosceles triangle, then I can use the cosine formula. Sorry, I should use another color to let you see clearly. Yeah, so this one, okay, so do remember is that I should use cosine formula instead. That means that do remember practically, okay, in a problem, okay, you may have to combine both formula to solve what you have, because in the figure itself it may consist of more than one triangle, so do be careful about this. Okay, so it's very easy. So happy Easter, and give you some works for you to do during the Easter. Okay, so these 8 questions not so difficult, but do remember is that using cosine formula just like sine formula, always keep all digits in the intermediate steps. That means that if your values would be used to find another value, so always represent all digits. That means that all 10 digits, so actually not all 10 digits, it should be the 10 digits from your calculator in your step, and then you use them always and press all the digits always when you use them to find another value until it is the final answer. You write in 3 stick figures as required. Okay, so this is just a reminder. So I think that this one is easy. Try to do. Ask me if you have any problem. Thank you and goodbye.